Hi guys, welcome to this new video on Docker. So in this video we'll be talking about Docker networking or container networking. So previously we have discussed like when we create a container using Docker. Let's say you are creating a container, Docker start, let's say Ubuntu. So what this does? So according to the containerization which we have discussed previously, like containers create a number of namespaces. Like one is bit namespace, one is network namespace, one is user namespace. These are and various other namespace. So what these namespaces mean? So these namespaces mean any process P1, P2, P3. Let's say these are the processes associated with this bit namespace. So the process tree of these processes, a set of processes, their process tree is isolated from the main process tree, like the root process tree, because these processes inside this bit namespace will not be able to see any other processes associated with. Let's say this one P1 and this is P2. So let's say here also you have PA, PB, PC, three processes. These two namespaces are completely isolated from each other. And what part of the namespace is the P namespace, which is the process tree. These process tree and this process tree are totally different. These processes don't know about this process and this process don't know about this process. Similarly, for network namespace, let's say you have two network namespaces. So a set of processes belonging to this A, B, C, let's say, and A, B, C. So a set of processes belonging to one namespace will not be able to see. This set of processes will have a completely different network interfaces, and this set of processes will have different set of name processes. So this will be X, Y, Z. So this set of these processes inside this namespace will have a completely different set of namespaces. Like here I have discussed. So you can see. So this set of processes which I have discussed, you can see a set of processes belonging to a namespace is completely different network stack from a set of processes in another namespace. So let's say this is your network namespace 1. This is network namespace 2. And you have, let's say, A, B, C, and X, Y, Z. These are the two namespaces that you have, and these are the set of processes associated with namespace 1, and these are the set of processes associated with namespace 2. So according to this, you can see like this set of processes and will have different set of network interfaces, and this set of processes will have different set of network interfaces. This will have different route tables, this will have a different route table, this will have different IP table, this will have different table. So you have completely isolated this set of processes from this set of processes. And what part of the thing you have isolated? The network. So this is how what this is what Docker does. So when you create a container, Docker start Ubuntu. So what this does, this creates a set of namespaces. One bit namespace, one network namespace, one user namespace. So this creates one. So now today we will be discussing about Docker networking. So we will be talking about this network namespace. So today's topic is about Docker networking. So we'll be talking about this network namespace which Docker does with. So networking is there's nothing different in like Docker networking and other networking stuff. It's same as the local like networking in general, like what Linux networking. So let's say you create so let's say this is your Linux machine and you created a network namespace here. This is your root namespace. This is a root namespace, and this is the network namespace you created in S1. So and so if you run if config here, you will see ETH0, you will see loopback interface, etc. And if you run if config here, you will get a loopback and not anything other, because there's no network interface inside that. So this is the difference. Here you can see this namespace. The processes inside this namespace will have only the loopback interface, maybe, or maybe nothing, because you have not created any network interface inside this network namespace. But processes inside this can see this ETH0, the loopback. So this is the difference of this is the benefit of creating a network interface. This process inside this network interface, this one will have a different set of network interfaces, and the process inside this root namespace will have this set of network interfaces. So this is the reason we create, like Docker creates like the network interfaces and the network namespace, so that it gets completely isolated from the host machine. So you can see running if config in root and ls will produce different outputs. This means they have completely different sets of network stack, but there is no connection between the namespaces. So now let's say this is the root namespace. Okay, so this is the root namespace, and this is the namespace the Docker creates, or you also may create. This is the NS0, and let's say this is root namespace, NS. Yeah, but these two, there is no connection between the namespaces. So there is one solution what we can do is like veth. So what is vth? Let's discuss. Vth is, just a minute. Yeah, you can see Linux provides the facility to connect network namespaces a virtual Ethernet using a virtual Ethernet, which connects the two namespaces. So when you create a virtual interface, it will be always be in pairs. Like, yeah, here you can see I have created one vth. So it is vth0 and ch0. So we can see with this single command, we just created a pair of interconnected virtual Ethernet devices. The name is vth0 and ch0. So what we can do is, like, we can keep ch0, cth, just a minute, ceth0. We can keep ceth0 here, and what we can do is we can keep veth0 here. So what we did is we created a tunnel between two namespaces. Now you can ping, like, this is your network namespace. So now when you are here in your terminal in the root namespace, you can ping this network interface inside this namespace. And also you can, what you can do, you can ping this one also from the network interface using the terminal here also you can do. So this is how you connect two namespaces. So this is what Docker also does. So let's go into Docker. So Docker networking. So so you can see when you create a container using Docker, it is assigned different namespaces. A set of process belonging to a namespace, which we discussed, is completely isolated from a set of process in another namespace. So Docker supports three types of drivers. Docker supports, just a minute. Docker supports three types of drivers. One is bridge, one is host, and one is none. So bridge, let's discuss about this thing. So as Docker gives us like a bridge network, a default bridge network to which your the containers you create connects to by default, which the name of this is bridge 0. So this is the default bridge network that Docker provides. And let's say you run a container site like Docker run Ubuntu. So you didn't mention any network, which network to use, but that's by default it will use bridge 0. So let's discuss now what is a bridge network, like bridge driver in Docker. So a bridge network is this. So a bridge network is a device that behaves like a network switch. It forwards packets between two interfaces that are connected to it. So let's say, what is a bridge? So bridge is in Docker, it is a software, but hardware bridge is also there. So what does a bridge does? It just forwards the packets between two network interfaces connected to it. Let's say this is your one container on one namespace, and this is one namespace. So what it will do, it just forward the packets. So, and since it's a bridge, not a router, it does not care about the IP addresses of the connected device because it operates in the L2 level. So here is a diagram. Let's say this is your VM EC2 instance. Yeah, so I guess, yeah, this is the bridge. I think you didn't see. So what it does is it forwards the packets when two containers or two namespaces are connected to a bridge. It just forwards the packets within the two namespaces connected to it. Maybe three, like the number of names. It just forwards the packets to the namespaces. That doesn't necessarily, it should be two only. So this is what the bridge does. So now let's say your VM EC2 instance with Docker installed. Let's say this is your, just a minute. Let's come to this. So let's say this is this is your EC2 instance. So when you run ifconfig here, you will get Docker 0. This is what I was talking about. This Docker 0 is the default bridge network that Docker provides, and you will have it 0. So what Docker does is, like, let's say this is a container 1 and this is a container 2, and it will have its own namespace. And what Docker does, it creates a cth1, which I showed you before, and this is a cth2 inside the container, and it creates a vth1 and vth2. And this, what is this? This is a virtual Ethernet. So what it does is provides a tunnel between the namespace and the root namespace. This is a host or the root namespace. So what vth and ch3 is just provides this tunnel from where it connects the two namespaces, because the container has its own namespace and this is the root namespace. So what it does is connect the two namespaces, and here also you can see cth2 is and vth2 are the other pairs, vth pairs, virtual Ethernet. So we talked about that, like virtual Ethernet always comes in pairs, and this is the bridge which this vth1 and vth2 connects to. So this is the bridge vth1 vth connects to, and what Docker, just a minute. And what Docker bridge tells you, in terms of Docker bridge network, uses software which lets containers connected to the same bridge network communicate while providing isolations from the connector that aren't connected to that bridge network. The Docker bridge driver automatically installs rules in the host machine so that the containers on different bridge networks can communicate directly with each other. So when you start a Docker image, this bridge that I talked about is created automatically. Newly started containers connect to it unless otherwise specified. You can also create a user-defined custom bridge. User-defined custom bridge are superior to. Yeah. So let's see what does this mean. So what does Docker bridge say is like, let's say this is your bridge network which you have created, and the containers connected to it like C1, C2, C3. This is, let's say, bridge 0. My own bridge, let's say custom bridge. So the containers connected to the custom bridge, these containers can like connect between each other. So what does it mean? This means like the containers that are connected to the same bridge network can communicate with each other. Let's say here is the container C4. So this will not be able to communicate with C1, C2, and C3 because this is not connected to the same bridge network. So this is the main thing, is like containers connected to the same bridge network can only communicate between themselves, and any other container which is not connected to the bridge will not be able to communicate between these three containers. So the main reason to use custom bridge is like bridge network is like communication between the containers. So reiterating the thing is like containers connected to the same bridge network can communicate between each other, and they're isolated from other containers which are not connected. Let's say here you have C4, C5, C6, and this is a custom bridge too. So the containers, these containers are completely isolated from these containers, and then we will not be able to communicate with each other because they are connected to the different custom bridge. Sorry, the different bridge network. So this is the agenda between in using bridge network. So let's see the practically see the bridge network which the Docker gives us. So if I do Docker network, so these are the like commands which you can use. So let's see Docker network ls. So you can see this is a bridge 0 network which the Docker creates, which the Docker gives us by default. So now let's create our own network, bridge network. So for that, what we can do is like before that, let's inspect this, and Docker inspect. So you can see this is the subnet, so 172.0.17, and all the new containers visually will get an IP from here only. So to prove that, let's create a container, Docker images. Let's see, I have any images or not. Yeah, I have Docker run ITP Ubuntu. So Docker, yes, yeah. So let's inspect this image. Sorry, container. So you can see it has got this IP address 172.17.02, and when we when we inspected the Docker 0 bridge network, you can see it is 172.17.0.016. So you can see this container just created got connected to the default bridge network. So yeah, so now what we can do, we can create our new network interface, new network bridge, like Docker create network my custom bridge. I guess I did something wrong. Docker network created would have been. So I've created, let's see, Docker network ls. Yes, you can see it is the bridge driver, and let's inspect this. Yeah, you can see it got 172.18 by 0.16/16. So if I connect any if I run any container using this network bridge, it will get its IP from here. So let's check any container. If I'm running any container .docker yes, I will stop this container. Docker stop. Yeah, it doesn't stop. So what I will do, Docker remove. I will remove this container also. Yeah, so I will clean it. Let's clean it. And what we will do, we will write. We will spin up a new container with the network we created, with the name was Docker network ls. Yeah, my custom bridge. So what I will do, Docker start ITD net. Here I will pass the my bridge network. We just created my custom G one. Yeah, so you can see it has started. Docker, yes. Yeah, so let's inspect this container. So yeah, you can see that we have this 172.82 and the bridge network which we created. Let's check it. Yeah, it is 172. Here it is 172.18. So you can see it has got this IP from here. So this is how you can create a bridge network, and this bridge network. Let's say you create another container and you connect that container to this bridge network. So these two containers will be able to. So let's run another run db network is like my custom. So I am running two containers. Yeah. So let's inspect the new one. This also got 172.18. You can see. So these two containers are connected to the same bridge network, which is my custom bridge, and they will be able to communicate with each other. Now, if I do docker run ITD Ubuntu, now this is connected to the Docker 0, which I created here. So that this container will not be able to like communicate with the other two containers, which have its bridge network as my custom bridge. So this is how the bridge network works, and let's go to the second part. So now we'll be discussing about the host. We have completed the bridge one. Now we'll continue with host. So what is host? So we have discussed, let's say this is your computer or the EC2 instance where you have installed your Docker. So this is also Linux machine. So this will have its own network namespace, which is known as root. It will have its ETA0, it will have its loopback, it will have many others. And now when you create a container using Docker, it creates a one PD namespace, one user namespace. But while we are using this host driver for networking, this will not create any network namespace. What instead it will do, it will use this root namespace. It will use this host root namespace. So what let's say this is your container one. So container one will create its own PID namespace, user namespace. But in case of network namespace, it will not create any network namespace. In case of host, so what it will do, it will use the host like the host network namespace, and which is the like EC2 instances network namespace, root namespace. So this is how the host network namespace works. So let's see it practically. So Docker. So Docker, yes, Docker stop. I'm stopping all the containers right now. Yeah, I have stopped the containers. Now I will delete those containers. I don't have any containers. So now what we'll do, I will spin up the Ubuntu container. Docker run ITD network. I'll use host one. and Ubuntu. So let's docker ps. Yeah, I have a container running, and what I will do, docker inspect. So because I'm running the in like in Windows, like Docker Windows, Docker desktop, it didn't, I guess it didn't get the IPs of the host. But if you do it this thing in Linux, you will get to see the when you run ifconfig. It doesn't work here because I'm using Windows, but in this case I have used network host. So this should use the like the host network interface, and there's another one which is none. So let's discuss about the none one. So let's say this is your EC2 instance or your local machine or anything where Linux is installed and where Docker is also installed. And let's say this is your container and this is your root namespace. And this ETH 0 is a network interface loopback and many other interfaces you have. So this is your container. So now when you create a container using this none network driver, it will create a one PID, as we discussed. It will create a one user namespace, but it will not create any network interface. So this container will not have any network interface because the Docker will not create any network namespace. It will also not get it from the root namespace. Like there will be no network interface inside this container when you use none. So there will be no networking capabilities of this container. So let's see this. Yeah, so while using the none, so while using the none driver, let's say this is your this whole thing is your, so let's say this this is your Linux machine, and you have your root namespace here, root network namespace, which will have ETH0 loopback and many other many other network interfaces. And this is a container you created using Docker, but you have used network driver as none. So what it will do, it will create one PID namespace, one user namespace, and other namespaces, but it will not create any network interface like network namespace. And it will also not connect to any other network namespace like root network namespace, etc. This container which will create using the none driver will have no network capabilities because there is no network namespace, no interface is connected to this container. So this is basically what none driver means. So none will not, like when you use none as a driver, there will be no network capabilities of the container which uses this none driver. So let's see it practically. So I have a container running here, so I'll clear it and I will remove all the containers. So docker run itd network equals to none Ubuntu. So docker ps, I will get the container ID. See, it doesn't have any IP addresses. So this container, which is this container with ID this one, will have no network capabilities and it has no network interfaces. And also one thing I forgot to tell you, like you can connect a network interface and disconnect a network interface while the container is running. Like you can see, I have here. I have this container running, so I can attach a network, like attach the bridge network which we created, like Docker network. Yeah, so this custom bridge network I can connect to the container which is running now. I can connect this custom bridge network to this running network using the connect command. So what I can do, Docker network. You can see this connect command. I will use this Docker connect. Sorry, Docker network connect my custom bridge to this container. So I cannot connect it because let's spin up another container. Docker run ITD Ubuntu Docker PS. Yeah, let's connect to this one because it was none, so I was not able to connect to that. My network bridge paste. You can see I've connected my this one. So now let's inspect. It will have the Docker 0 and my custom bridge, both bridges it is connected to. So what I can do, I can inspect it. So you can see this is the my custom bridge and this is the Docker 0, the bridge network. So it is connected to both the networks. So this is how you can connect a running container to a network. You can also disconnect using the disconnect command. Network disconnect my custom bridge. Yeah, so you can see we have disconnected. Let's check it. Yeah, you can see that my custom bridge is gone and it has only the bridge 0, which is the default bridge which the Docker provides. So these are the three drivers which we can use using the Docker networking. And there are very other bridges also, like the world network, which we'll discuss in another video. So thanks for watching the video, and if you liked it, please like the video. Thanks a lot.